Last time we have already talked about the structure and properties of diamond. This time we would like to talk about another form of carbon, graphite. If you refer to this picture, you can see the structure of graphite. Similarly, graphite also adopts giant covalent structure. However, if you refer to the arrangement of carbon atoms in graphite, you can see that is a bit different. First of all, if you refer to the number of carbon atoms bonding to each other, you can see each carbon atom can form 1, 2, 3 covalent bonds with 3 other carbon atoms. Try to recall. There are 4 outermost shell electrons in each carbon atom. After forming 3 single bonds with 3 other carbon atoms, there is 1 electron remaining. As a result, this electron is delocalized. Later on, we will talk about how the property relate to these delocalized electrons. Go back to the structure. As the carbon atom can form covalent bonds with 3 others, so you can see the result is the carbon atoms form covalent bonds, and this result in layer structure, and in each layer it consists of numerous hexagons. So that's why we can say the structure is layered structure. Okay, this slide is what I have already mentioned. Now, let's talk about the result of delocalized electrons. As I mentioned before, as 1 outermost shell electrons is delocalized. That means there are numerous delocalized electrons which can move between the layers. That's why graphite can conduct electricity. On the other hand, as we know, we can find graphite from pencil. Why we use graphite in pencil? Because when we write, the graphite can be left on the paper very easily. So that's why if we refer to the property of graphite, we can say it is soft and easy to cleave and lubricating property. If you refer to this picture again, you can see some dotted lines between the layers. Actually, the dotted lines means the weak van der Waals forces existing between adjacent layers. As we know, compared with covalent bonds, the van der Waals forces are very weak. That's why the layers can slide over each other, contributing to the lubricating properties. Finally, if we talk about the melting point, we can also say graphite is very high melting point, because if we want to melt graphite, actually we can't only break the weak van der Waals force. Additionally, we have to break the strong covalent bonds between the carbon atoms. If we want to change the graphite from solid to liquid, that means we have to break so many strong covalent bonds, and that's why this requires a large amount of heat energy, and that's why graphite has a very high melting point.